This 5-degree taper that I'm referring to in a clay valve seat, it's right here is that area I'm talking about. This is a little exaggerated. Most seats are flat. In other words, a check seat's flat, a disc sits on it. Some of them are rounded, shaped like that. But anyway, there's relatively a hitting point on the top, whether it's a rounded, which has a relatively small area, or the flat, which has a relatively larger area. Well, the design of the check assembly has to do with that area in relationship to how much spring load it takes to do it. The clay valve design, what they wanted to do was come up with a very, very small point right here. And that small point, as I say, is generated by that 5-degree taper of that seat. This is exaggerated. A 5-degree taper would kind of be just like that. It's almost imperceptible, actually. But anyway, the reason they have that 5-degree taper is because it had to do with the flatness of that disc. Remember, it's a hinge or pivot style check. And like we talked about, the hinge or pivot style check has to have a perfect, where the disc hits the center of the seat, kind of like a golf swing. If it doesn't, it's off center, you lose your troubles with your differential loading. Well, clay valve has a relatively lower loading on the check valve. So by having this 5-degree taper, it was critical that this disc is perfectly flat as it first hits that seat right on the tip. And to hit that perfectly, it has to be within 5/1000ths of an inch. And that's why we have those spacer washers that we talk about to put the adjustments back in with 5/1000ths. Because what happens is, you know, it's got that bolt in the center here, and if we don't have the right amount of spacer washers when you punch that in, what happens is it bulges that disc out of there's a disc holder like this, right? And it bulges that disc. So instead of this sitting right on the point now you can see that that sealing surface is like this. So instead of sitting on one little point, now we're sitting on a relatively wider seat, and it's going to affect the way that our check loading holds. So that's why it's critical that we have that disc perfectly flat. We can't have a bulge into it, because if we have a bulge, we eliminate the advantage of the 5-degree taper by making it a rounded disc instead of a flat disc. Well, what happens if it's too thin? Again, if it's too thin, let's say the disc is up here instead of down, similar problem happens, because remember, this is a hinge or pivot style check. So if it goes to this point and doesn't hit that disc, it has to keep going a little bit farther, that much more distance. And as it goes down, now suddenly it's cocked. So that's why it's critical on the clay valve that it has to be literally within 5/1000ths of an inch, the flatness of that disc. If there's any kind of bulge like that, it negates the 5-degree taper. If it's too low inside here, same story. It's going to negate the 5-degree taper. So this is the 5-degree taper on the clay valve seat, and why it's so important to have that disc perfectly flat within 5/1000ths of an inch. So to make sure the height of this disc with this disc holder on it is right, because you can see that if it was too thick and I pushed down with this bolt on top of here, it would squeeze that rubber out of the disc holder, and I would lose the advantage of that 5-degree taper. So how do I make sure I take up the tolerances between this plate and this plate? And that's basically what I'm trying to do with these 3 spacer washers. These spacer washers are the gray ones are 5/1000ths of an inch thick, and the red ones are 15/1000ths of an inch thick. So with 3 of these, I can make up between 5 and 25/1000ths. In other words, there's 5. I put 2 together, there's 10. I take 1 red, it's 15. A red and a gray is 20. A red and 2 grays is 25/1000ths of an inch. So that's how I'm going to make up that 25/1000ths of an inch tolerance on this disc in relationship to this disc holder and disc retainer. So how do I size that? Every time you rebuild these, you have to size these spacer washers. I've heard people say, oh yeah, you take them apart, you put the same color back as you took out. That's not true. Every time you take the disc out of the disc holder, you have to resize it, because that 25/1000ths is that close of a tolerance. So you start with the smallest, which is 5/1000ths, and you place it so that it's sitting across the bolt hole, just like that, okay? Covering up the bolt hole, I'm going to go ahead and put my disc holder on top and just hold it with my finger. And as I hold it with my finger, you can see where it's sticking right there in the middle of the bolt hole. So what I want to do now is see if it moves. It moved very easily, didn't it? So that means the tolerance between these two is more than 5/1000ths. So now I get 2 of them and go to 10/1000ths. Same story. Place it over the bolt hole. Place my disc retainer over there just like this. And it moves very easily again. So I haven't taken up the tolerances. Now I go to 15. With that across the bolt hole. Now suddenly it doesn't move. In other words, just with the light pressure of my thumb, it's 15 thousandths. So that tells me that the tolerance between here is between 10 and 15. 10 is too little, 15 is too much. So we go down to 10. You go to the smaller of the two numbers. Because remember, we're going to tighten this bolt on there, and that's going to take up the tolerances between that 5 thousandths. So putting my O-ring back on, now I have it so this disc stays perfectly flat. But it could be anywhere from 5 to 25 thousandths that you have to make up on that particular check design. The only one that's different, that is the 10-inch. 10-inch disc retainer has a ring like this with 16 screws, and the 16 screws going around it like this. There is a washer on the back side of each screw that is one size. You don't have to size each one, but you do have to plate that spacer washer on the back side of the 10-inch, which is slightly different. But the most of them, 2-inch through 8-inch, are going to be a single bolt like this with an O-ring under the bolt. Don't forget the O-ring under the bolt. Size your spacer washers accordingly, and putting it back together, making that perfectly flat will make your repair job a lot easier. Now, that's a 308-1, as I said. 308-4, Chevron disc. 308-1 new style is this style of disc. It's just a little bit wider. What's different on the 308-4, and that's the one you see here on the right, as I mentioned, the difference in the 308-4 had to do with the disc and the disc retainer. If you'll notice, when I unscrew the bolt off the 308-4, we have that same O-ring. Disc retainer, we have our spacer washers. What did this one take? This one has 20 thousandths, one in the gray, but the disc is separate. Also notice that the disc holder is different. Notice that they put this area around the seat right here. One of the problems they had with the 308-1 style check assembly, especially in the 2 through 3 inch, is that the check assembly tended to have a rattling action. And I'll show you here. In other words, when this disc holder was here, it could bounce around like this. On the 4 through 10-inch size, there was enough mass in the disc holder that it really didn't have as much problem, but when the 2.5 and 3, it was more prevalent. And they actually had a small rubber bumper that was inserted in the back side. Well, the 308-4 style check, they put this extra gap around here. And what happened is the check assembly opened, this kind of quieted down that clapper so that it didn't have that rattling action, which unfortunately could cause harmonic resonance in some issues. So the 308-4 style, the main difference is this valley around the outside of the disc holder. Still had the same tolerances we had to deal with the 308-1, meaning the 25 thousandths or less. So you'd have the same spacer washers issues that you wanted to deal with that one. But the disc holder did look different. The check seats did not have this quiet zone. It was just a plain seat without that sleeve on the back side. So that's our 308-4. Here's our 308-1. Again, we're going to do the same basic alignment of those spacer washers, regardless which one we have. Okay. Now that we've got that back together, we tighten that bolt all the way down. We're ready to put it back together. So, let's get this in place. Put that like... So, our check assembly, again, this has a flat disc retainer like this. In the RP versions, some of the disc retainers looked like this. And they had these fins across the disc retainer. The majority were flat like this. You find it in the older versions that had the fins. The function of this fin design was that as the check assembly opened like this would turn up into the water passageway, and if you're looking through the water passageway, what it would do is it would be called a straightening vein. In other words, as the water traveled across those veins in this position, it straightened it as it traveled past this port right here. What's right here? Well, that's where our relief valve was mounted, right? So this being off a 6-inch, though not a 4-inch, as it opened up, it would open up right about here, and when it opened up in this position, it made it so that there was not a lot of turbulence as it went past that relief valve opening. Again, the older versions had this. Make sure if you do have this kind that you put it in straight up and down like this so that when it does open it up, it creates that straightening action across the relief valve inlet. Now, grabbing my clapper assembly, again, hanging on to both sides so we do not have it fall into the seat. I'm going to insert it in from here, catch my spindle, and push my spindle in from the side. Now, I've got to be very careful at this point because I have to pull up on my check assembly. In other words, right now it's sitting in there like this. Okay? As you can tell, it has to go like this so that it moves up and down. It is possible to put the clay valve check mechanism in like this. And if the check mechanism has the yoke pointing down like this, now suddenly it cannot open. In other words, the yoke has to be up here so that as there's demand for water, this swings up into the water passageway. So it's critical that when I put this in like this, that I keep my hand on the knob right now, pulling up on it like this. As I'm pulling up on it, now I grab this rear yoke, line it up with my holes, and go ahead and insert my spindle in just like that. After you've got it in, make sure that that disc holder moves up like that, because this is how it has to be inside the body. If it's like that, you'll get no water through the valve and then it'll never work. Check spring, cover O-ring, check cover, get our bolts back in, O-ring seal on the check. Now, on the 8 and 10 inch, you want to be a little careful because as you can see, this is a 4 inch and there's not a whole lot of spring tension that comes under that cover. But on the 8 and 10 inch, the spring can pop up about 2 or 3 inches and the bolts are only about 1 inch high. So if you're concerned with the load on the first check of an RP on the 8 and 10, a jacking screw, which is just a piece of a piece of all-thread rod that goes in here that's a little bit longer than the bolts. That way you can release the spring tension easily off the bigger, meaning 8 and 10 inch size assemblies. Now, I'm putting it back together. That's what it looks like. The last thing I have to check on this is the alignment of my check mechanism. In other words, now that it's back in place, what I want to do is see where it sits in that check assembly. And how I'm going to do that is I'm going to look at the impregnation of the disc on the seat. In other words, I'm putting it back together. Now I want to take it out, because I want to take it out one more time like this and see where the seat ring is pushing on my disc. In other words, back together like this with the spring tension on top, you'll see a small little imprint where the rubber disc was sitting on the seat. I want to look at that imprint and see where it is. It should be in the very center. If it's not in the very center, now we have to adjust our body bushings. And what are our body bushings? These little brass bushings that spindle is inserting right there. How do we adjust those? Well, yes, we have to take the check assembly back out. The body bushings are designed so that if I have to move it one way or the other, in other words, if it's off to this side and have to move it to this way, that means I have to drive this bushing into the body. The cover bolts happen to fit right inside, I can't see that one, happen to fit right inside the bushing just like that. What that allows me now to do is to take a small little driving rod and hitting the head of that bolt. I don't want to hit the front of that bushing because that's what it's going to slide on. So by putting the bolt from the cover, now I have something to tap onto, and it's a very light tapping. Don't think you need a hammer real heavy to move these over a little bit, because all you're doing is moving it over no more than 1/16 of an inch, usually, if at all. And if you have to move it the other direction, where it has to go into the body, what happens to fit is on the up to 4 inch, a 1/2 inch piece of copper tubing fits through here, hard copper. And on the 6 through 10 inch, there's a 3/4 inch piece of copper will fit into that bolt hole, where plug hole where the plug goes in. And that's if you have to move the bushing sideways. But only check it after you put it back together, checked it closely, make sure the alignment is square in the center of that disc holder. If it's not and you have to adjust the bushing carefully, do it. For the average repair, you do not have to adjust those bushings. You do have to do those spacer washers every time, but the body bushings are usually okay. But if you go to all that trouble and then you find out that it's not centered, it's not going to work well. So let's get this back together again. Check spring, cover, our body plugs. We're going to have 4 of them around the outside where the 2 spindles came out. And that's the toggle lever check design. Whether it was a 3081 check, like this, 3084 check, like this, the different disc diameters, as we discussed, had to do with the serial number, a way of adjusting them. The key thing is making sure we adjust between the 25 thousandths of that rubber thickness on the disc retainer. If we have the old style seat that has the sleeve, we have to make sure that it's clean so that the water will travel through those holes. In other words, where that sensing line comes through, making sure that the water has adequate volume of water to work the relief valve. If you've got the old style thin disc retainer, making sure that's in there properly. And that's the 3081, 3084, sizes 2 through 10 inch. Here's what the poppet style check assembly is going to look like. We just saw the 3081, 3084 design in the larger 2.5 through 10. And although they did make us 3081 style in the small size, 3/4 inch and a half, the majority that were produced looked like this in poppet style. And the poppet style had 4 bolt covers on the top. Removing the 4 bolts, there would be spring tension underneath that check cover. So you want to pull the bolts off, hang on to your cover carefully. Cover came off, O-ring seal, check spring, check disc holder, check seat threaded into the body and could be repaired could be replaced if the check seat was bad. Average repair wouldn't be needed. There were 2 different designs of disc holders in this over the years. As I mentioned earlier, there's going to either be a stainless steel version, which is the older one, or the Delrin plastic version. Whichever one you had looked like this. Oldest version being the stainless. They had some problems with some erosion concerns and corroded away and had problems where these did corrode, and they replaced it with a plastic or a neutral material that didn't corrode. But if you have the old stainless steel type, it was 1 nut, hold the disc into the disc holder, go ahead and change the disc. Again, the same basic construction with the O-ring on the stem. Check disc holders slid into the cover like this. That's how it was guided through its travel. It had that octagon shape here, you see, like this. The plastic one, which was made out of a plastic called Delrin, looks like it's a one-piece design because there's no screw to take it apart. You actually held the disc holder and the stem and twisted the two. In other words, the disc holder had the female threads, the male threads were on the stem of the stem. There was an Allen head slot right there, so that once you got it together hand tight, you get your Allen head wrench to tighten that back up. Reassembly is going to be just the reverse. Again, if you had the stainless steel version, the rubber kit would fit either stainless or, yes, I know I'm not putting a spring back in there, would be either fit either one. The rubber parts would fit both designs. Plastic was the more common one, produced over the years. Check spring next. Make sure when you put the covers back on, you had the air screws pointing up, not like this, because if the air screws are not pointing up, you're not getting the air out of that assembly. See how this one is on the top where I'm bleeding air out? I can put the cover to the side like I did on this one, but if I do, I'm not going to be able to bleed the air out of that particular check body. So make sure the air screws are pointing up like that. And that's the poppet style check valve from Clayval. It could be the poppet made out of plastic, the Delrin, or it could be the stainless steel design as we saw. This appeared in the model D2 double check or the model RP2 reduced pressure assembly. Now we'll discuss the relief valve used on the Clayval. We've discussed the 3081 and 384 check assembly and the poppet style check assemblies, and those were the different checks. These are the 3 different relief valves you would be mounted on one of those assemblies. The oldest version, which was this one, which is called the CDHS 14, and this was used, the 1-inch size was used on 2 through 2.5, the 1.25 was used on 3-inch, and the 2-inch CDHS 14 was used on the 4 through 10. Looked like this. The CDHS 20, which was used on the RP1, RP1EX series over here. Again, the 1.25 one was used on the 2 through 3, and the 2-inch used on 4 through 10. And the CDHS 24, which were using the same designations as the CDHS 20. So there's 2 basic designs, meaning the CDHS 14 and then the 20. And the 24 is a variation of the 20, which I'll show when we take those apart. So let's do the oldest one first, the CDHS 14. Rubber repair parts are limited available on this. They're making them on the sizes 4 through 10 inch, I believe only, which is the 2-inch CDHS 14. This being a 1-inch version, which fits on the 2 and 2.5 inch. There are 4 bolts on the top. To rebuild it, we have to unscrew the relief valve from the check body. 2 external relief valve sensing lines. Remove the 4 nuts off the top. There will be a slight spring tension from the relief valve underneath. Remove the relief valve spring. You'll expose a stem with a wrench flat and a nut. There's also another wrench flat and a nut on the bottom. You need 2 wrenches. Hold the bottom as you unscrew the top nut. Once you take the top nut off, the upper bellow-frame and bellow-frame retainer come out next. Next is bellow-frame support. Then there's a small stem O-ring. Next comes the upper bellow-frame body, which comes off here. Spacer washer. In the middle of there's a small little bushing that sits there with 2 O-rings in the center. Next, the little friction washer here. Then we have our bellow-frame plate. Lower bellow-frame. Bellow-frame support. Lower body. Lower bellow-frame. Lower bellow-frame holder. Stems come out from the bottom with relief valve disc. So those are the parts of the CDHS-14. Disassemble the relief valve stem. You have 1 nut on the bottom. Comes our disc and disc holder and stem O-ring right here. Reassemble is going to be reversed with our stem O-ring, our relief valve disc. This nut has to be tightened on here very tight. Now, inspection of this relief valve stem is important on the CDHS-14 series. Here's the 1-inch stem, and here's a corresponding 2-inch stem. As you can see, they look identical. The key thing is this white Delrin bushing here. This Delrin bushing slides up and down through the center of that relief valve body. And it's very important for the relief valve opening point that that's on there properly. So what you want to do is grab it, make sure it's not loose. It's a shrink fit on the stem, and making sure that it's perfectly smooth. It should not have any scars or markings in it. Now, to reassemble, we have to put the stem in first. Relief valve seat stays under the bottom, is not removed for the average repair. But in order to assemble this properly, we have to assemble everything along this stem. And if I let go of the stem, you'll see that it falls down, and it's not going to be easy to repair. A small little piece of paper or rag will hold the stem up just like this for our assembly process. And I removed a bolt so you can kind of see how it goes. Okay, so first thing is our lower bellow-frame retainer. Our lower bellow-frame, which goes on here, which sits in the middle through here. So, like that. This, we're going to go ahead and line it up. Now, there are breather holes on both sides of the bodies. Because there's 3 rolling bellow frames in here, one side's open to air and one side's open to water. You've got to make sure that those air-breathing holes are open, like we've seen many different assemblies so far. And here's another one that we have to make sure everything's working just right. So, let's go put that on first. Put this on next. And now, take this, and just, there, and that should move in there like that, okay. Next is our lower large bellow frame, our plate, our friction washer. We're going to replace the 2 O-rings in our body, place our spacer in the middle. This is also a very important part of the relief valve opening point. This has to move easily through here. If that green, which is like powder coating they put on there so that it will move and move easily, goes along with that Delrin bushing, which is sitting in the middle of that stem. Now you'll notice that there are 2 connectors. Make sure the upper connector is on the top, pointing towards our inlet side. At this point, our second friction washer on the other side of the bushing. Our lower diaphragm plate, our small stem O-ring right there. Now we're going to put our upper bellow frame retainer. Go ahead and tighten that nut back on. Now, whenever we have a bunch of bellow frames, we know we don't want to twist them. We've talked about that several times today, so we're going to get 2 wrenches, one on this side and one on that side, and tighten that very tightly along that stem. Very important that we have them tight through the whole area. We don't have the advantage of an O-ring in that seal, but we have 3 bellow frames that we have to make sure are in there tightly. So, this, once that's done, cover and relief valve stem. And that's the CDHS-14, which was used on the model RP, the original version of the clay valve relief valves. Now we'll talk about the CDHS-20 and the 24 relief valve. Here in my hand, I've got a 3/4 RP2. Here's the CDHS-20 relief valve in the 3/4 inch size CDHS-20. Here's the 1.25 inch CDHS-20, which went on the backflow assemblies sizes 2 through 3 inch. And they had a 2 inch CDHS-20 that went on the backflow assemblies 4 through 10. CDHS-24 was produced, which was a revision of the CDHS-20. The bodies look dramatically different, don't they? Where the 20 is rather short and the 24 is rather long. But other than the bottom of this body, and I'll show you what's different inside that with that depth of the seat and why they had to change it, they have the exact same rubber repair parts inside. So let's go ahead and take the CDHS-20 apart for now. Here we're taking apart the 1.25 inch, which fits on sizes 2 through 3 inch. On the top, we're going to have some screws that hold on this upper portion. And on this upper portion, you'll notice there is a breather hole. Where is it? There it is. That small little breather hole is very important for the workings of this assembly. Anytime we see a breather hole like that in a cover, we know that that means this relief valve breathes, meaning that the air moves in and out. This is not a water port, but an air port to go let air in and out of there as a rolling diaphragm moves up and down. And as I've just said, when you take the cover off, you'll see a small inner roller diaphragm. Rolling diaphragm on this particular assembly causes a lot of problem on repair. We'll talk about that when we put it back together. One nut on the top. Our upper bellophram bushing. We have a small relief valve stem O-ring. Our upper bellophram plate. Once we have those parts off, now we'll remove the relief valve upper body bolts. Under the bolts there will be spring tension from the relief valve spring underneath. As the bolts come off, the relief valve upper body comes off first. You'll notice that there is a Delrin sleeve in the center. This is very important because it slides up and down along this stem. Has to make sure that that's perfectly smooth inside there. Doesn't have to be repaired for the average repair, but just inspect it to make sure it's perfectly smooth. Most of the CDHS-14 and 20s, the fitting that attaches to the relief valve body, you'll notice in the center there's a piece of plastic which is an orifice fitting. In other words, it looks like a standard 3/8 by 1/8 inch flare fitting adapter on there, and they break off unfortunately regularly because they're very small, that 1/8 inch pipe thread. But a lot of times they get replaced with an average fitting and they don't notice that there's that small piece of plastic in there. That's an orifice fitting, very important for the working of that relief valve. It has to do with the amount of volume of water on and off the top of the relief valve diaphragm to make sure how it opens smoothly. So make sure you know it's there and don't arbitrarily just put a fitting on if it breaks off. Relief valve stem is next with our relief valve disc, relief valve spring, and the lower relief valve body is our relief valve seat, which does not have to be replaced for the average repair but unscrews out of the top if it has to be replaced, just like this, sealed by an O-ring underneath. The relief valve stem has one nut that holds the disc retainer into the disc holder, relief valve diaphragm, stem O-ring, lower diaphragm plate, and our relief valve stem. Now, the relief valve disc is encapsulated within this disc holder, and the edge of the disc comes all the way back to here, so it's way, I'll stick my screwdriver in it so you can see how far down it goes. It goes down that far. So it's way back inside. You have to dig the disc out of the disc holder, and especially with the older ones, because it's a relatively hard disc, it can be hard. They've got a small hole here on the side which allows you to take a piece of wire to push the disc out if you're changing the disc and you can't dig it out through the top. But just as important, when you go to put it back in, it's very important that that disc sits all the way into the lip and is pushed all the way back into the disc holder. Okay, reassembly is going to be the reverse. We start with our stem, lower diaphragm plate, stem O-ring, our diaphragm, RV disc and disc holder, disc retainer, and our lock nut. Making sure that's very tight. Yes, there's an O-ring seal in the middle, but we want to make sure that we have that properly loaded on the O-ring. Relief valve seat. Now, this is the CDHS-20, as I said, and the rubber parts between this and the CDHS-24 are very similar. What's different on the 20 and the 24 is this disc holder here. This is the CDHS-20 disc holder, and this is the CDHS-24 disc holder. Notice where the relief valve seat is, very, very high. This is attached to the check body on the side. So if that relief valve disc closes up and down like this, water coming in here would go through this seat to discharge. But you'll notice that that seat is that far above the bottom of that body. And if this was attached to the side of that body like it was on the RP1 series, remember on the RP1EX they put it underneath the body, theoretically this much water could stay in the body and it could not go out of the relief valve seat because it's at the highest point. So what they did on the CDHS-24 is they lowered the relief valve seat all the way down to here. Now the relief valve seat is at the bottom of this throat. So what does that mean to the relief valve disc holder? This. So the CDHS-20 is stainless steel and it's flat. The CDHS-24 is a plastic, but it's much deeper so that it goes all the way to the very bottom of this body. That's the main difference between the 20 and the 24. 20 had the relief valve disc attached right to the diaphragm and the relief valve seat was up higher. The 24, they cut this out and removed it and put the relief valve seat on the very bottom, and that's why they had the longer throat on the disc holder. Main difference between the 20 and 24 are those two pieces right there. So let's go ahead and put the 20 back together. Relief valve spring, our relief valve stem. Going to line up our relief valve our diaphragm into our bushing. Now, remember that this is attached to the side of that check body like that. So we have to make sure that our sensing line is attached to the right place to catch our relief valve sensing line. Doesn't do any good to rotate it over here and then we can't hook up our sensing line. So make sure we have it attached for our sensing line. Go ahead and get our cover bolts in. And it's always better to put your bolts all the way in around before you compress that spring, because as you compress that spring it can pull the diaphragm down. Catch the relief valve body bolts like that. Alright, now, that relief valve stem moves up and down, as I say, with our diaphragm trapped through here. And I mentioned that this upper diaphragm is a guide. Well, that's because there is water in this upper portion. You can see the stem here. Our high pressure sensing line puts water on the top side of that diaphragm. The low pressure sensing line comes through internal through the body through here. But this upper portion acts as a guide, as I mentioned. We always said the most important part of every part is the guide of every component. And the lower part's guided by that disc holder through the bottom part of the seat, but the top of the stem is guided by this rolling diaphragm right there. So this is what guides the top and guides on the bottom like this. But the problem is this rolling diaphragm is directional. It only goes one way. You'll notice up close that there is a relatively shiny side and a relatively dull side. That's because this relief valve rolling diaphragm is directional. It only goes one way. The side of it is perfectly flat, so we don't have a bevel to look at like we do on most other designs to determine which way it goes. And if you think about it, the shiny side is watertight because it's got an extra layer of rubber across it. Where the back side that's dull, you can actually see the fabric inside that rolling diaphragm, so you know that that cannot hold water. If you put this in upside down, meaning the shiny side pointing up, water comes from here and will actually push its way through. And what will happen is after a day or two, you'll see these little pimples develop and water will start shooting out this little breather hole right there. Because what happens is it rubs back and forth on that fabric and ruptures itself. The smooth side needs to be facing down. Remember, water's coming from this high pressure sensing line and coming up. The top port is open to air, so you don't need the water seal on the top. Bottom is where you need the water, down there. That's where the shiny side goes down against the water as it comes up. Okay, let's go ahead and reassemble it. Get our leaf valve diaphragm retainer, our upper stem O-ring, our diaphragm with the shiny side facing the water, the dull side facing up, stem nut. Go ahead and get that tight with a proper wrench. Now we can roll our rolling diaphragm down. Now at this point we want to stroke the stem, make sure it moves easily through its travel. If it doesn't move easily, we're going to redo it and check it again, but it should move very easily. You can pull up on the diaphragm like that to make sure it moves easily up and down. Rolling in place. Remember our little breather hole right here? Always point the breather hole towards the back. Now you want to be careful when you put this cover on. You don't just want to shove it on like that, because if you do, you have a good chance of smashing that rolling diaphragm. So put it on the top with 2 fingers, working it back to make sure you don't affect the roll, and have the breather hole pointing out this way. That way we have a visual indicator away from the check valves if you start leaking water out of there. And what may happen again is if you don't put that shiny side towards the water, and you put the dull side there, you're going to have the problem of the water shooting out of that cover. So remember, dull side to air, shiny side to the water. And that's our CDHS-20. Here's our CDHS-24. The only difference being the location of the relief valve disc holder. On the 24, it was longer so that the seat could be on the very bottom, and in that way that the whole relief valve body could drain, as opposed to the CDHS-20 where the seat was up here, and unfortunately the whole half of the body of the check and the relief valve could sit in if there was a backflow condition. And that's our relief valves for the clay valve models.